going to be doing another experiment. Today we are going to be going over our conductors and poor conductors experiment. Another name for poor conductors is an insulator, which we are going to figure out today. So the main question you're going to be asking yourself today is, how does heat move through materials? So we're going to be looking at some materials let heat pass through them quickly and others don't. So what you need to have open and already into your science notebook is this experiment page. It says, which spoon will melt butter fastest? You need to have that already in your science notebook page. If you have not done that, please pause this video and go do that now. Okay, this means that you've followed directions and you've already put the video in here. Okay, so we are going to be thinking about our hypothesis. And remember, as scientists, they need to make a hypothesis before they start an experiment or they start doing something. So we have our burner down here. I'm going to tilt the camera so you can see down on our desk. But here's our picture. Here is our burner with, it's on hot water. We have our butter, metal, wood, and plastic spoons. So I'm going to lift those spoons up for you. Okay. So we have a metal spoon, a plastic spoon, and a wooden spoon. Okay. So we are going to be putting some of this butter on the top of our spoons, and we are going to see which one melts the fastest. So we are going to see which spoon will melt the butter the fastest and which spoon will melt the butter the slowest. Your hypothesis, which Miss Mevin helped you down here, needs to be exactly as I think the metal, wood, plastic, whichever one you think, spoon will melt the butter the fastest and or the slowest. You need to have two hypothesis statements followed by because. So at this time, please stop this video and go and do your hypothesis. Right now, you should have just written your hypothesis, but I need every single one of you to go back and check. Did you use the word because and give a reason for your answer? Because if you didn't, then you didn't write a hypothesis the correct way. You need to go justify why you are going to do this. Now, remember, a hypothesis doesn't have to be right or wrong. We are going to go over all of that with you. So please take this time. If you haven't, go back and make sure your hypothesis is written the correct way. Okay, so Ms. Mevin's going to go to the next slide for us. All right, so now we are going to do the experiment. All right, so I'm going to get it on my phone, and we are going to do the experiment with the burner. Okay. Okay, so we just watched the experiment. I'm going to show you guys what happened to our spoons because our spoons are not the same. I'm actually going to show you on a picture. And you have to figure out which one melted the butter the fastest. So now that you've seen that, I want you to take 2 minutes to write down what you saw in your experiment. Talk about what actually happened. We want to talk about what heat transfer melted the butter off the spoon. Now, some of you would say that it's convection, where you'd be wrong. It is actually conduction, because even though it is melted, it is still a solid. This is still a solid on a solid. So it is conduction while the bottom of the spoon heats up fastest. So this is actually an example of conduction. The water boiling is an example of convection. The pot on the burner is an example of conduction. Okay. I'm going to share my slides because that's really hard to read for you. So let me share my slides with you.
So for our reading, it says insulators and conductors, but insulators and poor conductors are the same thing. All right, so heat moves through some material more easily than others. A conductor is a material that heat moves through easily. Many metals such as iron, aluminum, and tin are good conductors, which means heat travels through them very well. If you put a tin tray in the oven, it gets hot quickly. But wood is not a good conductor. Heat does not travel through it easily. Wood is known as an insulator, or you can call it a poor conductor. An insulator is a material that limits how much heat goes through it. Many cooking tools have wooden handles, like the one on the board. This is so the handles of the tools are not too hot for a person to touch with their bare hands. All right, so now we're on the page with the blue. Marble is often used in ancient times to create buildings and monuments, which is the picture you see there. It's an ancient Greek temple made of marble. Marble is strong and looks beautiful. It can survive fires and erosion with little damage. Marble is an insulator, or a poor conductor, same thing. This makes it a very good material for buildings. It can keep buildings warm and cool. It can also keep them from catching on fire. Plastic is another insulator, but it does not work alone in keeping its temperature. Plastic usually has many little air pockets inside of it. Air is an insulator, or a poor conductor, as well. Together, the plastic and air that make up a container help food and drinks keep their temperature while the container's temperature does not change. And then the picture at the bottom, the caption says, "These refrigerated mushrooms will stay cool, insulated by the plastic container and the air inside of it."
So we were talking about what is a good conductor and what is a poor conductor. Now, once again, a conductor is a material that heats up quickly, but also cools down very quickly. So my spoon, which was so hot that Ms. Mebane burnt her hand on it from how it melted off our butter, is now able to touch, along with the plastic and our wood. Now, I want to show you the plastic without dripping butter all over Ms. Mebane's carpet. The plastic looks like this now. So we were saying that metal is a good conductor. It heats up quickly and it cools down quickly. But plastic is a insulator, but it's not a great insulator because of those little air pockets and those that it does have the tendency to melt. So if you have like it depends on the thickness of the plastic too. I have butter all over. Okay, so a poor conductor or an insulator is a material that heats up, does not heat up quickly, and they take a long time to heat up. That was like our plastic and our wood. It took a long time for the butter to melt, but they hold heat a little bit longer. Okay, so now, now we are going to be doing the after reading. So now that you know what a conductor is, know what an insulator is, know what happened in our experiment, you need to go to the bottom of your Save Science Notebook page, and you need to answer the question, after the reading, what actually happened? Which spoon heated up fastest, which heated up slowest, and why? You have to explain why. So I'm going to give you a few minutes to do that right now. Okay, last thing that you are going to be doing is going back to slide 7, which is our heat transfer, our unit question, how does heat move? Where you were supposed to each day after our experiment explain how heat's moving. At the bottom, you need to explain what conductors are and what poor conductors or insulators are. So please, please, please go and do that right now. So you are filling out page or slide 7 on that right-hand slide. Thank you guys for following along today. We hope that you followed everything. If you did, your entire slide is completed, both slide 7 and slide 20. I'm going to go with 20.